Thank you. Yeah. So Rexford, talk to me about primary keys, man. What did they talk about in the workshop with them?
So a primary key is a unique key in a table, a unique column, or it's used to identify like every row in the table, like a unique property number that's used to identify every row in the table. And a foreign key is a unique key in a different table that's used to relate those two tables.
Yeah. And talk to me maybe about what's the relationship between a primary key and a foreign key. And feel free if like, and folks, anytime I'm asking questions, if you want to, you can always pass the baton or phone a friend or whichever game show metaphor you prefer. But so yeah, what's the relationship then between a primary key and a foreign key?
So a primary key is a property of that table, whereas a foreign key is from a different table.
Yeah. And a foreign key is used to form relationships between tables and table. If we have table A, table B, this isn't put the best way, but table A is foreign key. Man, I think I'm going to go to a diagram in a sec here because there's a great program that we're going to use. Like usually a foreign key points to some other table's primary key. Yeah, and I'm gonna, I think, use a diagram in a moment to show that. And in fact, we're gonna just start building that. Any other, just to throw it out to the class, any other things about primary and foreign keys that they talked about in the workshop yesterday that are of interest or stuck in people's minds and stuff?
Yeah, sorry, just to understand. So is that just like when we have like school ID where it's school_ID versus the name of another file .school ID? So it's the same thing, but it connects the two?
Yeah, exactly. And in fact, I'm just going to show our lecture here because it's very much on point. And I think what I want to show too is, actually, let me put that there. Yeah, and to answer your question, Maya, I'm going to use this tool that we're going to be using called Quick Database Diagrams. It's pretty cool. It's linked to in the exercise for today, which is how I found out about it. And to kind of use the example that we're going to look at today. And it's nice because you can, like in this tool, it draws some visual relationships and you can type stuff out. It's not proper SQL, but like we might have professors and we might have classes or courses. And a course is going to have, so a professor, let's say they have an ID, maybe a first name and a last name. We'll add more stuff later. And the course should probably have a name too. And it needs a professor teaching it. So we'll call that professor ID. And that's going to be the ID of the professor teaching the course. Let's see. I'm not actually sure how to type it in the notation for this tool, but the great thing about this tool is it lets you do visual stuff too. And here they did it for me. So like if I typed this in, this would have formed the foreign key. And I think this is exactly what you were saying, Maya. Is that correct? Like the relationship between the foreign key professor ID here on our courses table and the ID the ID column, sorry, on our professors table.
Yeah, so like this one, the one up top would be professors.id, and then you're comparing that to courses.professors_ID.
Exactly. Yeah. This column professor ID, and we'll build this in a moment, but like we would create a new course, and let's say the professor ID is 3, and then that's referring to over here in our professors table, somewhere there's a row for a professor whose ID is 3, and that's the person who's teaching the course. And this is our foreign key, and it refers to the primary key of this other table, and that's kind of how you form these relationships. Because the primary key, and the reason you see foreign keys like point to primary keys in other tables, because the primary key is like what we use as like the guaranteed unique identifier of something. You know, there could be 2 professors with the same first name and so on. And so when we declare something a primary key, we're saying, hey, like this has to be unique for each row. Otherwise, how can the database tell the difference between 2 rows in that table? Yeah, good question. Did that make sense to folks? And do people have any questions? And yeah, Terrence, I'm glad you like the app. I like it too. I think it's amazing. I definitely can't take credit for it. Probably our director of education found it. Someone found it and linked to it in one of the exercises for today. There are a bunch of tools too that will use actual SQL, but I like this because this is just really straightforward. Cool, and let's go ahead and build some of this stuff. And I think that's what I want to do next. And so here in Visual Studio Code, I've done a little work. We've got a file, an SQL file where we will add our schema, sort of a scratch file where we can add like select statements and insert statements and stuff like that. Insert statements, excuse me. And I'm gonna do just a little setup here because I want to do a couple things. So I'm creating 2 terminals. And this one I want to drag over here actually and put up in the editor because it's going to make it really easy for me to jump around. So just FYI for folks, I always forget this is here and it's kind of cool. And here I'm going to log into Postgres by using PSQL. And I believe -L shows me the names of the different databases. I kind of created one here already. But let's create another one just for fun. And I've got, whoop, this is the challenge with this stuff. I have a little cheat sheet that I'm going to use. And if you bear with me, I will share it with everyone too. Here we go. So I'm going to throw this in the chat because I don't remember off the top of my head how to do everything with PSQL. So we're going to bring it over here. Has all sorts of great things. And I want to create a new database. So here we go. Pretty straightforward. Create database. And I'm just going to call it school. And I would recommend for now, folks, I would recommend just watching. If you want to follow along, you can. I know that it can be tricky to do both. If you know one method works for you, go for it. But yeah, for the moment, I would say watch and walk through and ask questions and stuff like that. And it'll be like sort of mob programming. And now we have this new school database. I'm going to use the connect command to connect to that. And now I ran into the same issue that Zainab had yesterday, which was how to clear stuff in Postgres. And in fact, I even Googled this and now I forgot it. So I'm going to Google it again. You folks can't see it, but
maybe a \!!
Yeah, thank you. That's exactly it. Awesome. And what I want to do now is let's write some code here in our SQL file. Let's start building our schema. And then we will run it. And we're going to make a table. And here's how you define a primary key. Did you folks see the serial keyword in the workshop at all yesterday?
I think they used a different method.
How
Yeah,
did they do
so
it? Yeah, Terrence,
they
please.
they didn't use serial, but I'm pretty sure Raphael explained that all it does is just like increment whenever you create a new row, just automatically adds the next number, sequential number.
Exactly, exactly. And that's something that you want to do with primary keys. You don't want to, this actually happens with the Pokemon API, like the Pokemon IDs almost guaranteed are like primary keys from the Pokemon table. And I remember a student and I kind of ran into this. You don't want to expose like database primary keys in your API, generally speaking, because that's a potential security risk. So I'm just going to add some info here. So we have stuff. Text is sort of my go-to. Might be good to add department later. Anyone know how to comment in SQL? In a .SQL file?
Double dash.
Double dash, thank you. And we'll talk about department when we get there. But we've got this. MySQL, I think it's looking good. Let's go ahead and run it. I believe the command to do that is \I, a directory path. I started this in the same directory where the file is, so it should be okay. In fact, if it's in the same directory, I don't think I need a path. And let's see what happens. Oh, okay, I've got an error. I need to add the semicolon at the end. And now it should be correct. That one I left out on purpose just to point out the value, I think, of typing the SQL here where we get nice help from VS Code for syntax issues, and then running it here where we get nice error messages. And it looks like I'm still got something missing. Let's get rid of that. Maybe it doesn't like the trailing comma. Yeah.
I was just going to say the trailing column like that was the problem.
Yeah, I think you're right. Thank you. Awesome. And now let's create, to refer back to our schema diagram here. I think it's nice to have both when building this stuff. We want to build a course table now. And it's going to need a name. And then, and like, if I'm writing SQL, like I might rename this table, to be honest. It's pretty clear what it stands for, that it's the ID of the professor teaching the course. But like, it never hurts to be explicit. And there are a couple ways to add foreign keys. One very straightforward way is to use, Postgres has a verb called references. And we get this great sort of autocomplete that's almost perfect from VS Code. And so here's one way to do it. This references variable is going to create a foreign key for us. And it means also with the foreign key, like we can't create a course that doesn't have a professor teaching it, which I think is what we want, though we may change our minds on that. And I'm going to pop over here and I'm going to run this again. And so note that I get an error because it says relation professors already exists. That's referring to that professor's table. But that didn't stop our code from executing. Like it didn't stop execution entirely. It went on and created this new table. And now I believe if I do /d, I should see the tables. And I believe if I do /d, the name of the table, I get some info on it. So this is really handy because we can just keep on adding to our schema. And we don't care about this error message, to be honest, now that we understand what it means. I think that's a good lesson too. So now we've got the course, we've got professor. let's go ahead. I see, yeah, questions. Great time to pause for questions. Alicia, is schema just your table layout? What do you mean by table layout?
Just all of your tables, essentially.
Yeah, so
Have your
schema is
database
like
laid out.
Sorry, I didn't mean to interrupt you.
I just said, so like basically how your database is laid out with the different tables.
Yeah, exactly. It's the schema, and I don't even know where. It's like the blueprint or the skeleton or the table layout. So where our tables are defined, and also where we define all the relationships between our tables. And you can have a database like print out a giant SQL file with its schema too, which can be a useful thing to do. Yeah, that's a really good question. And I see someone, Michael, see primary key generated by default as identity. They said serial's outdated. Okay, well, we should definitely change that then. And that actually leads, that's a good moment. If I want to change a table, did we go over this in the workshop yesterday? Updating a table?
Yeah.
All right, how can I do that? So we can use the different way to define the ID primary key on our professor's table.
So it's like update, and then you put which table, and you put set then set, and you pick your parameters, and then values, I believe is how it goes.
What?
Set, I think it'd be like professors dot ID.
Oh, I see what you're saying. Yeah. Let's see what happens. And by the way, there's no difference between this and this with SQL. SQL looks for that semicolon as the indication of like when an individual command ends. And this isn't critical, but this is actually a good thing to do, especially if the example's out of date. And I've got a syntax error. And to be honest, I think I'm going to circle back to this because I feel like I could get stuck on this, and SQL syntax is always a little finicky with primary keys. If we really wanted to, what we could do is we could do like drop table professors and just redefine it. And in some ways that's actually cleaner. And so I believe, does this look correct to folks for the newer, better way to do it in Postgres to define a primary key?
It should be after primary key, it should say like generated by default as identity.
Like
So
so?
like this, I'll post in the chat, but this line is like the whole line.
Oh, I see. Interesting. That is cool.
So to be honest, I mean, I understand they said serial's outdated, but I mean, it seems a lot easier and quicker. So I don't see why you wouldn't use it.
That is a great question, Terrence. And to be honest, like at this point, and this pops up all the time, like when you run into a situation like this, what you got to do is you just got to go Google it and find out the difference. And like, you know, unless we're doing Postgres all day, this is like, I don't know this off the top of my head, but I know that we can all find it out quickly. And like,
You forgot the
Yeah.
comma at the end of your
Thank
primary
you.
key.
Yeah. And the key is kind of knowing like, hey, there might be a difference and it might matter. It's almost always like an edge case or something relatively small, but then it makes a big difference. I think I'm just going to pause on this because I'm going to get lost if I can't do it this way. And we do have it working for now. I think you're totally right. Like, hey, this is working. So we can always revise it later. When you're learning, I do think like running into those moments and taking that 5 minutes to Google really pays off. That's something I've done over the course of my career. And I think you pick up all these like small things that help a lot. So I just want to kind of move forward though. And I think what I want to do is I want to create a department that the professors are going to belong to. And that's going to have an ID. And we know it's going to have a name. And now we do need to update our professors table. And we need to add another foreign key because I want to be able to say like what department a professor is in. So let's try this and see if this works. And this is another way to define a foreign key, and it should be alter table professors. And in a moment, I'll jump to the diagram too to throw it in there. Add constraint. Department, I'm just going to call it department ID. And so this is the other way to do this. Foreign key. Let's see here. Let me make sure I have this right, actually. A constraint course professor. I see. I need to flip this around a little bit. Bear with me 1 sec while I get this right. So hopefully what I just did now is connect a professor to a department. And let me go ahead and run this.
Adam, you're missing
yes.
a couple of semicolons after line 12 and 17.
Oh, thank you. Oh yeah, I just kind of threw stuff in there, didn't I? Thank you very much. And I want to clear. You might get a couple errors, and now we can kind of see. So these errors we don't care about. Relations, professor already exists, courses already exists. So this one we do care about. Department ID referenced in foreign key constraint does not exist. So I need to add a column here. It's probably what I need to do. Alter table of professors. So I might need to tweak this just a little bit. So let's try this. ID. Let's see if this works. If this way doesn't work, I think I know how we can simplify this. Honestly, I think I just want to go with inside the create table. Yeah, integer references. Curious if this works the way we want. Yeah, so I apologize. I think, I did a little research on this yesterday because our curriculum shows kind of two ways of adding foreign keys, and one uses references and one uses a couple other steps. I did a bunch of Googling, and the consensus is that they're effectively the same thing in Postgres. So I would recommend simply using references for now, because it's much simpler. And that did appear to execute successfully. And if you look here, we've got a departments table. And if we look at our professors table, we now have a department ID integer. And we have right here under foreign key constraints, let me make this a bit bigger for folks too. And this is great because we get some more information here. Indexes we don't have to worry about. Foreign key constraints. And here this tells us that the department ID column on our professors table is a foreign key that references the departments table. And we can look at departments real quick too. And we can see here, it tells us, hey, that the professors table references this. And this is cool too. Like it forms all these relationships. There are things you can do so that if you'd like delete something, it could delete the tables that reference it and so on. I'm just going to quickly add here departments. And our diagram will begin to expand. And let's do, then up here we need department ID. Let's see if I got that right. Yep. And I'm just going to kind of move stuff around so we can kind of see what it looks like. We'll put professors up here and departments here and courses over there. So let me pause and check in and see what questions people have about this stuff. Yeah, Francisco.
So is the entire purpose of putting the constraint just to make sure that the data that you're intaking into the table is the correct type, such as like integer, if that's what you're using as a key?
That's a really good question. Sorry, go on.
Because I might be wrong, but you could just add the column without doing the entire constraint thing. So is that the purpose of the constraint?
Right. That's a really good question. So with any column on a table, whether it's a foreign key or primary key, we're kind of adding these constraints of data types. Whether it's an integer, we're going to see we can add if it can be null or not. And there's a bunch of different options. With foreign keys and primary keys specifically, those constraints are to form relationships. For instance, right now, if I tried to create a new professor, I don't give them a department, we're going to run into an issue. And I lost. There we go. There it is. I just couldn't see it. So like right now, sorry, I'm not sure why that's happening. That's a little weird. Insert into professors. And let me look at my schema. So there's a couple ways to insert, as you guys probably saw yesterday. Let me quickly review because I want to insert the way where I name the things I'm inserting. Yeah, I want to do it like this. Insert into professors. Let's just say first name, values, Alice. So did you guys see this syntax in the workshop yesterday?
Yeah, we did.
Okay, awesome. right? So we want to add a professor whose first name is Alice. Did that work?
You need to put a semicolon.
Oh yeah, thank you. Right, and the clue should have been, I didn't see an insert from the piece SQL tool. Okay, so that actually did succeed. And I need a colon again. So, right. Yeah, I'm not gonna lie, I actually would have expected the references foreign key to require us to add a department ID, but that's actually good because like maybe we have a professor, but we don't know what department they're in yet. And here,
do
let's
we have
try.
to-
Yeah, sorry.
I was just gonna say, so for that, do we have to put not null in order for it to require it?
Yes, I believe so. I think that's exactly right. And I'll throw an example of that in our schema in a moment. And this is what I wanted to get to show to your question about like the value of like foreign keys and primary keys. I try to create a professor. It's okay if we have the same name because name isn't unique, with a department ID of 3, and we get an error that it violates a foreign key constraint, that this key doesn't exist in departments. So when the relationships that we form with foreign keys are really valuable because this is like our model of the universe. Like, we don't want a professor to belong to a non-existent department. We don't want a professor to be teaching a course that doesn't exist, right? And like a foreign key lets us build these relationships into the database. Does that make sense?
It does. Thank you. Appreciate it.
Yeah, that's a really good question, and that's like the core piece of the power of these relationships. Actually, my notes here, what I do want to add is, let me talk a little bit about the different kinds of relationships. So when we look at the different kind of relationships between tables, there's really 3 kinds that we care about. A one-to-one relationship, we haven't modeled yet, but an example might be like an address. If we had users and addresses and we decided a user could only have one address, or an office, a professor should probably not have more than one office. And maybe we want to make that a rule. And so a professor can only have one office. A one-to-many relationship, those we have modeled. A professor can teach more than one class, right? Professors can teach more than one class. And maybe professors can belong to multiple departments. And this is a good example of a choice that as a software developer, we might have to make or ask when we're tasked to do this. Like I might ask my manager, like, hey, do we want a professor? You know, sometimes they teach courses in different departments. And maybe my manager says, yeah, professors teach courses in different departments, but they only belong to one. And that's, you know, they report back to the department chair. So a professor can only belong to one department.
Wouldn't that still be one-to-many? Because a professor only has one department, but the department has many professors, right?
Oh, yeah, you're right there. You're totally right. Thank you. But a department has many professors. It's a great example of why it can be really valuable to model this stuff. And many-to-many would be like a student can have, we haven't modeled students yet, but a student can have multiple courses. And a course has multiple students. And Dalton, I know you have a question as well.
Yeah, it's just honestly like I don't really get the file structure. Like So do you have to have a schema in all of your databases, or could you technically make a database without one?
Yeah, that's a good question. Let's just Google this because I want to get this term correct. Okay, so this is really what matters. The schema, that's a term that we use to refer to the structure of the database described in a formal language, in this case, meaning SQL. So like, we can put like, you know, instead of doing this in a file, maybe I do this from the PSQL command line. Maybe I have each of these in different files. Once we like start creating tables and relationships, the database is storing all that information. And actually, let's see about printing that out. Postgres, PSQL. Let's see if we, I might have to pause on this. Yeah, I'm going to circle back to this, but there is definitely a way, like the schema gets created in the database, no matter how we do it. It's these create statements. Anything that creates or modifies tables and adds relationships builds our schema, and that lives in the database. And we can't see it here. I think it actually stores, I think the Postgres database engine actually like stores schemas in a database. I don't know if it's in this Postgres database or somewhere else. I would say it's not uncommon to see like one file where you start to create all this stuff. With Django, we'll see there's a migration tool that Django has, and there's a standard way to do this because it is really important to document in code like how we built up the schema, because you don't want to have to go to 1,000 places to find the source code, because just getting the database to print it all out can be really messy, or even worse, not have any source code at all to see how the database is defined and stuff. Does that help give a little clarity on
Actually,
that?
like that's what confuses me so much, because I'm assuming you would have so many people working on like one database or like just pulling from it. Like if someone went in and created a table without putting it in the schema, would that mess up your project, or would you just have to find it another way?
Right. That is a really good question. You're asking like, hey, what if a member of my team like logs into PSQL and creates a new table there and doesn't write any source code and doesn't check it into GitHub? That's definitely a bad practice that you wouldn't want someone to do. And that's kind of like part of our job as software engineers and like kind of what you learn as you get going. There might be situations where that is appropriate for whatever reason, but you really want to be, you always want to like be able to kind of reproduce stuff, because what if we have to like start another database on a new server or something like that, and we have to build a second one, for example, or just as you pointed out, we have to know what's going on in the source code. And if people are kind of creating stuff willy-nilly, then it's really hard to track what's going on. Yeah, that's a really good question. Did that help?
Yep, thank you.
Awesome. Yeah, really good question. So yeah, and I want to pop back to our diagram for a sec. And unfortunately, I don't think off the bat, it sort of tells us that we have one-to-many relationships here, actually. This is a common, yeah, it's hard to see, but like over here, there's like a vertical line, and over here, there's like a sort of triangle, and that indicates like one to many. And same thing here, like each professor has one department, but a department can have many professors. I know that's a little hard to see. It'll be easier to see when you folks are working on this yourselves.
Well, how did you tell it that? Because like you said, I mean, how did you tell it it's a one-to-one or one-to-many?
Right, that's a really good question. So one-to-many relationships are pretty common. And because our primary key is unique, like we know that there can be only one chemistry department. Let's just pretend that that's the ID without getting into like ID verse names. And we haven't applied any constraints to like how many foreign keys you can have. You know, that's a good question. I don't feel like I'm doing a good job answering it. Let me do a quick Google and pause. And yeah, and I think the way to do it really, let's look at maybe how people do one-to-one relationships. And I think, yeah, this is probably how they do it. And to be honest, you don't write a lot of one-to-one relationships. In this example, like there's this office table, and this is the row, the column that we care about, this teacher ID. They're saying, hey, like an office, it's got to have a teacher ID. It's got to be unique. It references the teacher's table. So like you can make a column that's not the primary key be unique. And then that kind of forces a one-to-one relationship.
Well,
like
so
over
now that
here, yeah.
Sorry, I could be wrong here, but I was thinking through it. And for a one-to-one relationship, wouldn't they each have each other's foreign key, right? Like,
yeah, sort of, I think.
or like, wouldn't they each have a foreign key for the other one, right?
I think what we're gonna do is, in fact, I just want to copy what they did. Sorry, someone, I heard someone talking. Should not know unique. So let's just pause here for a moment. And actually, I think this is a good thing to talk about with constraints, because here we're seeing some new constraints like not, null, and unique. Like for this offices table, it has an ID. Really, we should have, you know, I mean, if it's an office, it really probably should be like building ID, and that's probably going to be an integer. And that could even be a foreign key. And maybe then an office. You know, this raises an interesting question of like, where do we want to store the address information of where each office is? And this is probably not the best way to do it, but I just want to do this off the top of my head. And now let's say this can't be null because it has to be in the building. And none of this stuff can be null. So not null is another kind of constraint, right? It's not about relationships, but here we're making sure that like we can't enter this bad data. And then here's the really interesting part, because the idea here is that each professor has their own private office. So again, we need an integer. We might even want to let this be null, or because maybe we create a new office and we need to put it in the system and we haven't assigned a professor to it yet. But so their example might need a little tweaking. And like the way we've done foreign keys before here is like this. And so this tells us, hey, like we've got an office. And in fact, let me add it here. And I'm just going to add these two things because those are really the only things we need for our purposes. And then after this, I think we'll take a break and then we'll do a little more schema design. So this shows us the relationship between professor and offices. And the way that we've defined this right now, there's nothing stopping us from creating like 3 offices and giving them all to the same professor, right? Does that make sense, Alicia? Like there's nothing in our SQL code that says, hey, like you can't create an office. You can't create like 3 offices and assign them all to the same professor.
Well, I was thinking, because if you, according to what you said before, that's still displaying a one-to-many. So
Yes,
I was
it
thinking,
is. Yeah.
So I was thinking that like office professor ID would be a foreign key to professors.id, but then professors office ID would be a foreign key to office's primary key ID. So the fact that they both have a foreign key to each other basically
I see
saying
what you're
they
saying.
have to
Yeah,
be unique and can only be one. It has to already exist essentially.
right.
And
So, sorry, go on.
then I was thinking that that would be what would indicate that that's a one-to-one relationship.
I totally get what you're saying, and you raised 2 really good points. One is like we get to decide kind of like how we structure these relationships. And in fact, we may not want to put the professor ID in the office table at all. So, and I think the issue, and I'll show you, and there may be a way to do kind of what you're saying. The example I found does it a little different, but we would need to tweak your approach because what happens here is we probably can add some constraints. We see like we have like some sort of self-referential.
You put
stuff.
offices.id, but it's just office.id.
Oh, thank you. Where did I? Thank you. There we go. That's the problem. Sorry. Yeah, so this is a good example. Like right now, what we have is we have 2 different one-to-many relationships. Like we can make professors and assign them a bunch of different offices here. And we create offices and we could assign professors there. We could add some constraints there and make that work. But I want to show a different approach to doing this. And what they add here is this unique is kind of like the kicker for, let's see. And in fact, I think I'll want to refactor this in a moment. Let's see how good this diagram is. Yeah, I'm not sure how good it
They
is,
both
but
have to be unique.
so that's a great question. Because professor.id is a primary key, it's already guaranteed to be unique. So the short answer is yes, and we kind of get that
Well, you
because
put
we're
that
using a
down there.
primary key. Sorry,
Well, isn't that what you did already down there?
down here.
Yeah.
Yeah. Oh, the difference is I didn't have unique down here before. Like this. Yeah. Like let me
I guess I don't understand because you're saying professors.id is already unique. So why would you add unique right there?
oh, gotcha. That's a great question. So professor's ID being unique means when I create a new professor, each ID of that professor for each row is going to be unique. When I create a new office, this has to refer to some existing professor, but and actually let me kind of jump to SQL terms because I see the confusion because we have 2 tables, different tables with the same column name. professor.id is guaranteed to be unique because we made it a primary key. Offices.professor.id is not guaranteed to be unique because we could have two different offices right now and assign them to the same professor. Does that make sense? I think that, yeah, that one's, I hear you on that one. I think I want to circle back to that because I think the best way to see that in action will be like by adding some tables, which I think we'll either do later or maybe after lunch. Like we might do some review between 1 and 2 because we have folks coming in at 2.
Oh, so I think you were saying basically if you have office 201, you could assign Professor, Adam and Professor Raphael to the same office.
Close. Think of it as if we have office like 201 and 202, I could give myself, like Professor Adam could have 2 different offices. In fact, let's.
So on that same point, I don't understand where in the schema are you saying that an office can only have 1 professor?
Ooh, excuse me. Yeah, that is a good question. So let's step back. Let me run this. Let's throw some real data in there. And then, excuse me, I think I'll change it is what I'm going to do. And I think that'll help. So let's do that for like maybe 10 minutes. And I'm saying that more for myself. So I just hit a little timer and then we'll take a short break and then we'll do a little more modeling. Let's just do this. Let's see here. Professors already exists. Eric, create table courses. It's over here. Let's see, what does it not like? Line 9. Does anyone see what they might be complaining about here? I wonder.
You're missing a
The
semicolon.
create table.
Got it. Yeah, I think the issue. So I didn't have it. This is actually a good point. I didn't have a semicolon on line 16 for this offices, but the error message here was talking about the next line down, create table courses. And so sometimes, that's just like the limitations of error messages. And I think and hope that will work. I think I might just have, yep. There we go. So all these errors are what we expect. They're telling us things already exist. And let's see what we're working with now. So now we have some courses, some departments, some professors. Should have an offices table. This is why I have the scratch file. Relation professor does not exist. That would do it. Professor's ID. There we go. And now we have our offices. And now we can create some stuff. So we created Professor Alice. let's create Professor Bob. Alice and Bob are kind of like classic made up names for programmer stuff because it's A and B. And we can see that we've got 2 professors. And let's go ahead and create some offices. And I think I want to look over. I added a lot of things here, and this is actually a great example of why you want to be careful with what you require not to be null, because now we have to add a building ID and a floor and an office number, or else it's just going to complain. So in fact, it's good to kind of be cautious. Like if I do insert into offices, building ID 1, oh, because it's not, yep. So let's go ahead and make 2 offices actually is what we need. Offices. And then we'll take a break. Building ID, floor, office number. And in fact, I think this is going to complain because we're going to need to add professors. And I need a semicolon. Okay. All right. We didn't add a not null constraint on professor ID. So this works. And let's do this again. And this actually raises a really good point about why constraints are valuable. We now have 2 different offices that have the exact same location, same building, same floor, same office number. And obviously that's probably not what we want unless there's some weird bureaucratic mess up. So I'm not going to do it now, but that's a great example of why we might want to add like it's called a composite primary key, and I'm not going to get into kind of how to do it now, but the building ID, the floor, and the office number of an office give us a way of uniquely identifying every office, like an address. An address is unique. And so there is a way in Postgres to say like, hey, for every new row, when we create an office, that combination of building ID, floor, and office number is a composite primary key and has to be unique. But we'll get more into that later. So now let's go ahead and do some assignments. And let's look at my professors and see their IDs, and ID 1 and ID 3. So I believe update. So I got to do select star from offices where ID equals 1. Okay, awesome. And I actually need to double check my format on how to do this. Yeah, okay, beautiful. So we're gonna do this. Update offices and set professor ID. Actually, let me do this here so that we have it in our notes. Update offices. Set professor ID equals 1, where office where ID equals 1. And let's do this for 2 different offices. So kind of as to your point, Alicia, we've got these 2 update statements. And what we're doing is we're giving one professor, two different offices. Does that make sense to folks? Cool. And I know I've been jumping around a bit, and I apologize for that. And I do want to make sure that that makes sense. And so a couple of these errors we don't really need to worry about. In fact, I'm going to simplify a bit by.
A professor spelled wrong.
Thank you. I'm going to put that in our schema. And then over here, update offices. Oh yeah. Let's try this again. Okay, and now we've got our updates. We have two offices assigned to the same professor. And we could do select and I want to do a join here just to demonstrate this.
Hey, Adam, while you're looking it up, do you know why
Yeah.
the professor's ID skipped from 1 to 3?
I probably created a professor and deleted it, or at some point, maybe like, yeah, I probably created a professor and deleted it. Almost positive that that's why.
Cool, thanks.
Yeah, for sure. Yeah, that's a good question. So let's do this. Select professor.name, professor.id, office.id from, oh, excuse me, professors, join. And this I will put in the scratch file too. Join offices. In fact, let's put this in the scratch file now because it's already getting big enough and it'll help me to see it sort of in the normal syntax. I think it'll be good for us to get all of our professors' offices. So let's do it like this. And this hopefully so I think you folks looked at join statements some yesterday. Does this make sense to people?
Can you just explain line 15 like briefly? I don't,
Yeah,
getting office ID.
yeah, totally. So what we're saying here is, and the thing with join statements is you kind of have to start to read them and understand them. You kind of have to start at the end. Because here is where we're saying join these, it's the from and the join, right? The select, excuse me, select from, we've all kind of seen, like get these columns from this table. The join says, we want to also get data from this other table. And the on is where we tell our query how to link the two tables. And we're telling it, hey, like join the professors and the offices table and combine them for each row where a professor's ID is the same as an office's ID. And in fact, I think we could even start with this. I think that'll work just fine. And I think I'm going to do that to start with. And I think what I'm going to do too is make a new file. And let's call it query. It's not the best name, but.
Hey, Adam.
Yes, sir.
In your query, you have it as professor.id, but it should be professors.id.
Thank you. Oh yeah, I always have trouble with that. Let's give that a shot. Okay. So, and in fact, we could type that out here, and actually that's pretty friendly. Star from professors join offices where professor.id equals offices.professor ID. Cool.
You did professor.id again instead of professors.
Thank you. Yeah, and I need it's not for a join, it's not where, it's on. There we go. And so what we're doing here is we're getting, and notice we have Bob, that's our other professor, right? And Bob doesn't show up because he doesn't have an office. And it's this on part of the join statement that filters and restricts stuff, because it's only grabbing tables where a professor has an existing office. And this is an example of how we have one-to-many here. Which is like, I know we kind of took the long road, but that was a really good question that Alicia raised, and hopefully this gives a little insight into that. And let me check in and see what questions people have, and then I want to take a break, but it's almost noon, so we'll check in. But first, what questions do folks have? Like, what can we dig into more? Are people feeling good about this? Or is this, yeah, Dalton.
Sorry, I guess I do kind of still have the slight question of, so it looks like you gave Alice the same office twice, but what if you tried to give Alice and Bob the same office? What would happen?
Right. So that's a good question. And my guess is right now, we probably could give Bob that office. Update offices, set professor. So that's a good question. And this actually touches on our database design. In our offices table, we have a professor ID. And right now we only have 2 offices. So I can't give 2 professors the same office because each office only has 1 column for the professor ID. Does that make sense, Dalton?
Yeah, and that to that point, is that like a PSQL thing where no matter what it is, you're only ever going to be able to insert 1 value into a particular column?
That's just, I would say, like a relational SQL database thing because of the type of the column, right? Like, and what you're thinking about, I think, Dalton, is like multiple rows. Like, that's kind of how you would tackle that stuff. And there's actually a different schema that we can use that's a bit better, that does allow us to assign multiple professors to the same office. But right here in this column, we define this professor ID column. It's got to be an integer. So it can't be a list of 2 different integers or anything else. It's got to be 1 single integer. That's the definition of the column. And that's not, you know, about primary keys or anything like that. Does that make sense?
Yeah, that makes sense. Thank you.
Yeah, for sure. That is a really good question. And I think what I want to quickly do is show a different way of doing this, and I'm going to do it here so we can just very quickly see it. And it's not perfect, but I just want to get the ball rolling. I think Raphael briefly mentioned this, but here's the other way of doing this. And There we go. So a different schema would be, instead of putting professor ID in the office, you know, because maybe we have the address and all this stuff, let's create a whole new table called office professor. And let's have that be like our matchmaker. And it stores the professor ID and the office ID. And then if we want to, then we can create as many rows that we want. And right now we don't have any restrictions on, you know, giving the same office to the same professor 5 different times, or giving different offices to different professors, but we can add those restrictions. I don't know the format to do that here, but we can, that's a great example of like a composite key in Postgres. And I think we'll look at that later, because I also want us to look at like another schema and schema design that is going to touch on this stuff. So what I want to do now is, because it's almost lunchtime, I think pause, answer a couple questions, and then if it's okay with folks, I think like let's take 20, not more than 30 minutes after lunch to continue the lesson a bit longer, because we started a bit late, and I've been going a little bit off on some tangents, but hopefully it's been useful. So I just want to check in and see what questions people have, or things that people are curious about, or I can show what a composite primary key looks like how we would make this a bit more useful. But yeah, how are people feeling? Maybe can I get some emojis just of confusion or happiness or thunderclouds or smiling kittens or anything in between? Okay, I'm getting a mix. I'm seeing some frustration. Yeah, I think a lot of this will, like, once you start doing it, it becomes a lot more straightforward. And while we've got a couple minutes, for those of you folks who do have questions or would like to review something again, now's the perfect time. And I promise you, because as you folks can see in Zoom, I think about half the class gave me emojis. So if you have a question, I guarantee someone else has the same thing. And one thing I could do is I could just walk through the schema that we have again. That might be good. So I just want to check in with folks.
Yeah, I just asked a little bit earlier in the chat if we could
Oh, thank you.
assign, could we just get like verification that that happens when you just assign the same office to a different professor?
Do you mean verification for what again?
Just put in the command to assign the same office to a different professor, like the SQL command, just so we can see that that's what happens.
Oh, yeah.
And
Yeah.
before you do that, can we confirm if your schema currently has unique setup in any of those types?
Totally. Yeah. So currently, it is not unique. And that's what allows us to do this. And this would be what we would change in the current schema with offices if we wanted to make it unique so that each professor can only have one office. And to answer your question, Luis, about assigning professors to offices, all we're doing to do that is an update statement. And so, like, update, let me clear so we can start from scratch. So let's look at our 2 offices. They're both assigned to Professor ID 1, which I believe is Alice. Let's assign office number 1 here to Bob. I want to, set. Bob is 3 because we deleted someone. And I don't think we need to type office ID. I kind of do out of habit because when you need that when you do joins and such. Let's see what I miss. Update offices. Maybe it doesn't like. In fact, I think it doesn't like that. Yeah. So that works. So in terms of what SQL gives us, just in PSQL, we just see success. So it is important to then check. And we can see here, office number 1 has now been assigned to a new professor.
So I run into that error a lot where I try to like make some sort of query or do whatever I'm trying to do, and then I'll like try to be like, I guess, extra specific where like you added the office ID, but
Yeah,
it doesn't let me for whatever. Is there a good way of knowing when you need to do that, or is it just trial and error?
it's just practice, to be honest. It's just finicky. Like as soon as I typed it in my mind, I thought, oh, SQL might not actually like that because we're not doing the join. Excuse me. So it's just practice, but that is why I like this setup of like using PSQL and putting larger queries in their own file. And you just kind of got to, like, there are online tools that you can like throw SQL in to validate it too, because you do need to like set things up to help give you good error messages. But that's just practice, to be honest. Yeah, that's a good question.
Hey, Adam,
And
so on your last the error message that you got, could you
say
go
that
back
again,
to that?
Rexford?
Could you go back to that other screen? Yeah, so you got that error message because you were missing the S in offices. That's why.
Oh, that's why. Okay. Thank you so much. I guess yeah. That just goes to show not to jump to conclusions, I guess, which honestly is something that I always have to kind of watch for. Rexford, thank you very much. I appreciate that. Yeah, so Dalton, some of the time it may be that S, and unfortunately, that is kind of SQL like table naming best practice to have them be plural. So we do want to do it that way. And what I want to do is very quickly. Yeah, I want to drop my database. Let's see here. Because I want to show us, I want to show us adding the unique constraint. Bear with me one moment here. Oh, I need the colon. And I'll just do it. Huh, what does it not like? There we go. So what I've done now is I deleted that school database that we've been working in. And I did it because it's a little cleaner, I think, like to have, to just build everything from a schema file. I don't want to mess around with altering tables too much and get lost in that syntax. And this is also a good thing to see, and just also a really good example of why it's valuable to like store almost all the SQL you write in a file somewhere. Because now what we're going to do is, so the way we were doing it was a professor can have more than one office. So that was the old way. A professor can only have one office. And this ought to do it. And I want to turn this into a comment. So now let's create our school database again. This is actually create database school. Yep, let's connect to it. And now let's use our schema. Relation professor does not exist. And let's see where that's coming from. It's coming from line 16. And again, it's the plural singular issue. So let's fix that. And in fact, what I'm going to do is I'm just going to do the whole thing over again. And to be honest, a lot of the times it's easier to just wipe everything out and start fresh for a lot of this stuff. And that's also, again, why I think it's really helpful to have most of your SQL in files. Okay, so this is cool. Relation offices already exists. I see, because I have it in here twice by mistake. So we'll do that. And what we'll do is we'll drop table offices. And if I look at my database, there is no offices table. And now I am just going to run the schema again. And all this stuff is because it already exists, and it's created our new table offices, which is here. And now let's see what happens when we have this unique constraint. And this is the last thing I want to do, and then we'll break. So let's see. Insert. And this is where, like, I always need to look at a reference, because things like, do I need to add into? I always forget. And honestly, this is also why I really love that there's like a history. I'm just going to push the up arrow until I find my insert statement. Yep, and indeed there is an into offices value 321. So we don't have a professor here, and let's see if this works or not. And that one does. And let's do it, and let's just add it to a new one. Let's update offices set professor.
Stop. Yeah, no, we're still in class. It's supposed to stop at 1, so it'll be stopping any minute now. How long is your meeting gonna last?
We're gonna
You're
wrap it up.
Huh? It's over? Oh, we're gonna have a coffee break?
Hey, Maya,
Okay,
your
I'll
mic's
tell y'all
on.
when I'm done.
But yeah, your mic's on, Maya, just FYI.
Oh, sorry.
No, no problem. And we do need to stop and break. And we're gonna do that in just a minute. And I think, yeah, insert into professors, name, value. First name. And all we need, in fact, I think, is one professor to do this. And Alice has an ID of 1. Update offices, set professor ID equals 1, where ID equals 1. And what we see, one of the offices belongs to Alice. And now, fingers crossed, we get an error. And we're unable to give Alice 2 offices because we're told it violates our unique constraint. And that's what we added over here. And so now we do have a one-to-one relationship between a professor and an office. And I know that was a bit of a journey to get there, but hopefully you folks can also see it's actually pretty straightforward, like how to kind of do this stuff. And especially diagramming it, I think it'll come like really smoothly. So let's break for lunch. after lunch, I want to walk us through building another schema for maybe 20, 30 minutes, and then we'll have some time for review or whatever folks want to do before the speakers at 2. So thank you all for your patience and for running a little long, and have a good lunch. And if folks have questions, feel free to just ping me out on Slack during the lunch, and I'll get back to you. So thank you.
What time are we coming back?